We've spent a lot of this unit talking about equations of circles, and we even looked at some algebra, some completing the square, so we could find the equations of circles. And that's been really the whole crux of the first three lessons, is finding equations of circles. Well, now we want to talk about how those equations of circles and equations of lines relate to each other. Okay, so now we're dealing with two equations. If you remember from algebra, that means systems of equations. A system of equations is anytime you have more than one equation. So let's look at a very simple system of equation to review our algebra that we did back last year sometime. So here we've got intersection of two lines. So we're going to solve for this system of equations, this intersection of two lines, which means what I'm really doing is whenever I have a system of equations, one of the easiest ways to solve them is by substitution. I'm going to take everything that y equals here and put it in place of y, okay? Now use your parentheses wisely here. So that's going to give me 2x minus, and now in place of y, I'm putting what y equals, negative 1/2 x plus 7, and keep everything else the same. So basically, all of this is what went in place of y, okay? Once we're at this point, now it's a basic equation, we just need to solve for x. So I'll distribute my negative 1. That's going to give me positive 1/2 x, negative 7. And always write everything out on your equation. Combine my like terms. I need a common denominator, so 2 becomes 4 over 2, and 4 plus 1 is 5. So that's 5 over 2x minus 7 equals negative 3. I'll move my 7 to the other side, so that's adding 7 to both sides. I'm going to slide over to this side of the paper here. That's going to give me positive 4. Now, a lot of people have a hard time with the 5/2 here. They want to divide by the fraction, and that's fine. Personally, I hate division, especially dividing by fractions. So instead of dividing by a fraction, which in element or algebra maybe you learned as keep, change, flip, we're going to do that a little different. Instead of dividing, I'm going to multiply. Instead of the fraction, I'm going to use its reciprocal. So I'm going to multiply by 5 over 2 in both cases. Okay? And that's going to make my life easy because 5 times 4 is 20. And whoops, I didn't do the reciprocal. Wow. This is actually the second time I've done this video today because I keep making mistakes. Let's fix that mistake. The reciprocal is 2 over 5. Haha. There we go. Fixed it. So that means that these two cancel. The 2/5 and 5/2 cancel. And 4 times 2 is 8. So that gives me x to be 8 over 5. But we're not done yet. We just solved for x. I now need to go back and get y. But I already know what y equals because up here I have what y equals. So I just need to substitute in the x value. So I'm going to go over here. I'm going to say, great. That means y equals negative 1/2. And in place of x, I'm putting 8/5. Okay? Don't be afraid of fractions. You got to get used to these and stick with fractions. Don't go to your calculator and give me decimal numbers. That's going to be negative 8 over 10. Remember, when you multiply fractions, you just multiply straight across. So negative 1 times 8 is negative 8. 2 times 5 is 10, which means now I've got to combine. Actually, I'm going to simplify that. Simplifying is nice because it makes the number smaller. It's negative 4/5. Whoops. Times 7 plus 7. And now when I combine that, I can change 7 into 35 over 5. That's the same thing. And negative 4 plus 35 is 31 over 5. Now, I did that in my head. If you need to write out on a separate piece of paper, that's fine. But now we have the intersection point, my solution. And in geometry, our intersection points are points. So write them as coordinates, which means they need parentheses around them. The x value is 8/5. The y value is 31/5. Some of you have been writing your coordinates without parentheses, and that's going to cost you points. So be careful, write your coordinates with parentheses. Okay, so that's a basic system of equations problem. Why don't you try one on your own? This one's a little trickier. So see what you can do. Find the intersection of the parabola and the line. Give it a shot. See how you can do. Might require some factoring, so be careful. Go for it. Okay, so hopefully you started off by saying, well, I know what y equals, so I can replace the y in this equation. So I'm going to go there and do that first. So that's x squared plus 2x minus x plus 7 equals -1. And now I'm going to distribute my -1. That's on the left-hand side. Give me -x minus 7 equals -1. Whoops, I lost my squared. In fact, since I have this squared, that tells me immediately I need to get things equal to 0 and factor. That's how we solve these quadratics, okay? So I'm going to combine what I can and get things over to one side. So x squared is by itself. 2x minus x is positive 1x. And moving the -1 over, I'm going to add 1 to both sides. So that's -6. And now I can factor that. This is a nice, easy factoring problem. I don't have to use any fancy ways to do this. I know that 2 times 3 makes the -6. And if I use a positive 3 and a -2, that gives me the positive 1 in the middle. So that means x has to equal 2 or x equals -3. Now, again, all of this is algebra from last year. Now I take those points and solve for y. So if x equals 2, then y equals 2 plus 7, which is 9. So one possible solution is 2, 9. If x equals -3, then y equals -3 plus 7, which is 4. So the other solution is -3, 4. And these are my two possible solutions for that problem. Okay? A little bit of remembering things. Now that we remember how to do systems of equations between two lines and a parabola on a line, we're ready to start talking about what happens with circles. So let's talk about lines and circles and some things that we've mentioned before. Give me some definitions. So first question, define what is a tangent line? Give me the definition. So hopefully you were able to say that a tangent line is a line intersecting a circle only once or only one time. Okay? So in that case, which of the lines here is a tangent line? Hopefully you're able to say line AB, or HB, I'm sorry. Line HB is my tangent line. Now in the Google form on all this, I don't expect the symbols. That's a little tough. Maybe you just said line HB. Okay? How about define for me what is a secant line? Give me the definition. Okay, so a secant line is a line intersecting a circle twice. Okay, remember it goes through the circle. Okay, so, ooh, I got things backwards, didn't I? Okay, let's fix that. Let's fix these examples here. My first example is completely wrong. HB is not this tangent line. The tangent line is EF. And the secant line is HB. Okay? So you saw I corrected that. Okay? Now that we've got that, we know the two different lines. Tangent line only touches at one point. There's my 1 point. Secant line touches at 2 points. Okay? And remember, these are actually lines. Even if I don't have the pieces here, even if I only talk about the segment part of it, it's still a line because tangent lines and secant lines go on forever, even though we may only look at the segment part of it. Now let's combine these ideas of tangents and secants to what we just did with systems. Okay? So let's graph a system of equations. Now, if you've got this on paper, you can graph this. Very simple thing. Remembering how to graph lines. When I graph a line, I like to know my slope, which in this case is 3, and my y-intercept, which in this case is 0, -5. Always write your y-intercepts as a point. Don't just tell me y equals -5, because remember, y equals -5 is a horizontal line. So to graph that, it's really easy. I graph my y-intercept, that's down here, and I follow my slope. So when I follow my slope, that's going to be up 3, 1, 2, 3, over 1. So I can graph that point to be 1, 2, 3. Make sure I got it. There we go. And now I can just use my straight edge to put a line through there. Let's see if I've got a straight edge tool on here. I think I might. There we go. Insert a line. Oh, let's get that in a color that I can actually see. Let's make that blue. Okay. Let's try that again. So insert a line. There we go. I'm going to take it the other way too. So there's my line. Excellent. Now, next thing, let's get the circle. I'll do the circle in a different color. Let's do the circle in green. For a circle, I need two things. I need my center, which in this case, remember our formula, x minus h squared, y minus k squared, and r squared. So since I'm not adding anything to x and y, my center is 0, 0. My radius is the square root of 25, which we all know is 5. So I can graph my center, 0, 0, and I'll graph my radius. So 1, 2, 3, 4, 5. Oh, this is really easy because I can just put it all the 5 points. And now I try to draw my circle as best I can because I'm not a good drawer. There we go. Now from this, I can now see my two equations. It's sometimes hard to tell what they are, or I'm sorry, my two intersection points, but I can see I intersect there and there. I won't really ask you so much to give me the intersection points on a circle unless they're very, very obvious, because I am not sure. I mean, I'm pretty good with that point. I know where that one is. That's at 0, -5. But I'm really not too sure where that point is. That's why graphing isn't always the best thing to do. But I can look at this and tell you that this blue line went through the circle 2 times. So since it goes through the circle 2 times, I know that it's a secant line. And there we go. Simple as that. So answering these questions with the graph is as easy as graph a line, graph a circle, answer the question. Let's look at another, okay? In fact, you try this one. Sketch a graph of it and tell me, is it a tangent line, secant line, or neither? Okay, so as you're doing this, hopefully you realize, oh, wait a minute, to work with my line, I got to get it into y equals. So I'm going to move my -1/2 x to the other side. So when I look at my line, it's y equals 1/2 x plus 5. So a slope of 1/2, a y-intercept of 0, 5. So 0, 5 puts me up there. And then I'm going to rise 1, run 2, rise, I'm do another point, and I'll get my line. Let's see. Good, I got my line still. So I've got a line going there, and I'm going to take it out the other way. So there's my line. Okay? You can use a straight edge to draw your line if you want to. Now I need my circle. Some people ask, hey, do I need to label my lines? Not really. Unless you have more than one line up there, I really know which line it is because it's the only line. So I'm not, in algebra, that was really important. And now, not as much. Okay? My circle, center of the circle should be at 2, 1. Make sure you didn't say -2, -1. That's a mistake people make. Make sure you get the x in the x place and the y in the y place. My radius is the square root of 25. Make sure you don't try to graph the radius of 25. That won't fit on the graph. So that means a radius of 5. So I'm going to go over 2, up 1. There's my center. Radius of 5. 1, 2, 3, 4, 5. That'll put me up here. 1, 2, 3, 4, 5. That'll put me here and down here. And I'm going to try to draw a circle. All right. This is a little tough. And it's really because I've got a terrible job of drawing a circle. So when I do that, a little hard to see whether it's a secant or a tangent or anything like this. If I were better at drawing a circle, we'd see that really this is just a tangent line. Okay, it only touches one time. But again, you can see the problem with graphs. You probably said secant, and you were like, but mine looks like a secant. And based on your graph, you're not wrong. In fact, based on the first circle I drew, that's not wrong. But that's the downside to graphing. So let's look at one more graphing equation, and then we'll move on to making this a better math problem. So try this one. Graph these two equations. Tell me, tangent, secant, or neither. So as you're graphing, you were able to say, okay, my line is easy because the line's already in the right form. My slope is 1. My y-intercept is 0, -4. So that's going to put me at this point, and I'm going to go up 1 over 1. I like going in the other direction as well, and I draw my line. There we go. Got my line drawn. Now I get my circle. The center of my circle is -2, 0. Okay, and a radius of 2. Square root of 4 is 2. So -2, 0 puts me here. A radius of 2, radius of 2, radius of 2, radius of 2. I draw this, and look what happens. This time, they don't touch at all. So it's not a tangent. It's not touching one time, and it's nowhere near it. So it's not touching 2 times. So in this case, this is neither. Okay? Excellent. But again, we ran into some problems. We ran into problems with this one because it looked like it did touch twice, even though it only touched once. We ran into problems with this one because I can see it touches twice, but I'm not exactly sure what those points are. So that's where geometry is nice, but algebra holds the answers. So we're going to actually solve these problems algebraically. So here I see that I have a circle and a line. I know it's a line here because nothing is squared. I know this is a circle because I see x squared and y squared. Okay, so rather than graph this, let's go ahead and solve this algebraically. So I'm going to do the same thing. I need to first do substitution. Well, the line, I need to get it either into y equals or x equals. Let's do y equals. So I'm going to set this up as -x plus 2. There's my line. And I'm going to take that and I'm going to substitute this whole thing in for y. Okay? So now I'm just going to substitute nothing else right now. X plus 2 squared plus, use your parentheses, -x plus 2 squared equals 16. Okay? That's just substitution. Okay? In place of the y, I put what y equals. So now, I got to FOIL these out. You might want to go to scrap paper when you FOIL this out. You might want to do it in your head if you can do that. So when I go over to my, you know what, I'm going to go over to scrap paper. So on my scrap paper here, I've got x plus 2 times x plus 2. So that's x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Okay, do that quick. That's just scrap paper. Ball that up, throw it away, no one knows. Because then I go, look, I'm a genius. I came up with this just out of the blue. And now I need to do the other one. Same idea. So this is -x plus 2 times -x plus 2. X times -x is x squared minus 2x plus 4. So x squared minus 4x plus 4. Excellent. X squared minus 4x plus 4. And don't forget the other side of the equation. It's an equation. Keep your equal signs. That's the hard part of this problem, okay? That really is one of the hardest things to do, is make sure you actually substitute properly and follow through on your algebra. Now it's a matter of combining like terms. So x squared and x squared is 2x squared. 4x minus 4x, well, that's 0. 4 plus 4 is 8. So that gives me 16. Now, again, I see I have something squared. So immediately, let's get this thing equal to 0. So 2x squared moving over 16 makes that minus 8. Now I know I got a factor. First rule of factoring, greatest common factor. So I'm going to pull the 2 out. That's going to leave me x squared minus 4. x squared minus 4 is a difference of perfect squares. Okay, that's a way of factoring that you should remember from your algebra. It's one of the easiest ways to factor. That's a perfect square, that's a perfect square, and I got minus in the middle. Okay, that's what you need to have. That's what it means when it says difference of perfect squares. So when I go to factor that, remember factoring this is one people loved in algebra. X minus 2 and x plus 2. Okay, so that means x equals 2. I got that one from this factor because for this to be 0, x has to be 2. For this to be 0, x has to be negative 2. What about that 2 in the front? A lot of people go, hey, what do I do with this? Nothing. Remember we said to multiply things, at least one of them has to be 0. So either this has to be 0 or that has to be 0. The number 2 can never be 0. So for this whole thing to equal 0, one of these two things has to equal 0. So to make that happen, those are the x's we have. All I need to do now is go find y. So I say, okay, well, if x equals 2, then y equals negative 2 plus 2, which is 0. And I got that negative from that negative x there. So when x equals 2, y equals 0. When x equals negative 2, then y equals negative 2 plus 2. Remember, negative and negative is a positive, so that's actually 2 plus 2, which is 4. So negative 2, 4. Look how many different solutions we got. I got 2 solutions here. So there are 2 places that the line intersects the circle. And if it intersects 2 times, that makes it a secant. So there's our answer. We know now that this is a secant line. And there's where it intercepts. So that's why algebraically it's so much better, because I don't have to worry about what it looks like. I don't have to worry about the fact that I'm a terrible drawer and can't figure out how to find a circle perfectly. With this, I can actually find it perfectly. Okay? So that leads you to a problem. Well, and here's a problem. In this problem, things get a little crazier, because now it's not just, oh, I need these 2 pieces. Okay? Look at our circle there. This is going to get a little crazy because I got a lot of things to go on here. So the first thing I would do, though, is I'm going to go, hey, I don't need to put this into the circle formula. I don't need to do all that completing the square because I'm not trying to find the center of the circle. I'm not graphing this. Okay? Let's just go ahead and figure out what x is. So 2 things I could do. I could get this into y equals. Let's say I wanted to get this into y equals. I would do this, and then that would move the x over here and the 1 here, but that gives me 1/2 x minus 1/2. Oh my God, there's a lot of fractions. I wonder if I can deal with it without the fractions. So I go, you know what? I don't like that. Let's get it into x equals. Let's move the 2y over. So that's positive 2y, and the 1 over. Ah, that's a whole lot easier to work with. So now I'm going to substitute that into my circle. Okay, so I'm going to substitute that for this x and that x. In fact, type out what that would look like. Okay, so hopefully you're able to say, oh, that's easy. I'm just going to take this x here. I'm going to start way over here. And I'm going to, let me change colors. I like the blue better. I'm going to make it say 2y plus 1 squared. Make sure it's y. If you change the x's here, it's going to confuse you later because the x's and the y's mean something. I also have to put that in place of the other x here. So 2y plus 1 there. And I just copy everything else. So there's my substitution. Okay. That I'm going to need to go ahead and multiply out. So this 2y plus 1, I go over to my scrap paper. I come up with that being 4y squared plus 4y plus 1. If you need to use scrap paper to do that, that's fine. Here, don't forget to distribute your 4. So that's 8y plus 4. Copy everything else. Okay. Combine my like terms. I've got 4y squared and 1y squared, so that's 5y squared. 4y, let's see, I've got a 4y, 8y, minus 2y. So that really ends up being, let's see, 10y. And then I've got 1, 4, negative 5. Oh, look, that's actually 0. That makes life easy. So that side becomes 0, and it equals 0 on this side. Now I'm ready to factor, okay? From here, I want to see if you can solve this using your algebra skills. See what you come up with for the solution for y. Don't give me the whole thing yet. Just give me what y equals. Okay? So the first thing you should have done is realized, oh yeah, factor out that greatest common factor. Y squared plus 2. Oops. Yes, plus 2. Oh, actually, no, I can factor out more, can't I? So let's erase that. Not just y, not just a 5 I can factor out. I can factor out 5y. So that leaves me y plus 2. Okay, now again, y plus 2, that has to equal 0. That one's easy. That happens when y equals negative 2. But also, 5y has to equal 0. This time it's not just 5, because 5 can't equal 0, but 5 times y could equal 0, because I don't know what y is. 5 times y would equal 0 when y is 0. So my two solutions for y are 0 and negative 2. Now take those and find me the points of intersection. So I take those back up to here. If y equals 0, then x equals 2 times 0 plus 1. So x equals 1. So my point of intersection, be careful of this, is 1, 0. Because the x value is 1, the y value is 0. A lot of people just mix that up. They always put the first thing they found first. Getting my next part, if y equals negative 2, then x equals 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is negative 3. So my solution ends up being negative 3, negative 2. Again, two solutions. If there's two solutions, the line intersects twice, so it's a secant line. Okay? That's really all there is with this. Okay? Not much else to do with this. So, last thing first. You know what? I'm not even going to look at the next one because I think you guys, well, yellow, why not? Let's try the next one. Try this one on your own, and then we'll go over it, and then we'll take a look at things. So tell me, what are the points of intersection? Secant, tangent, or neither? Okay, go for it. All right, so you got your answer. I'm going to go through pretty quickly, okay? So to finish this off, I already got it into x equals, but it's negative. So I'm going to make it x equals negative 2y minus 4, okay? Not dealing with the fractions. Put that into my x value. I'm not going to square this out. I'm just going to plug this straight in, okay? Substitute first. That's less x's I got to deal with. Now, I will simplify what's in parentheses. Always, if you've got a chance to simplify in parentheses, do that. It really does make the problem, well, simpler. Hence the term simplify. Okay? Whoop, 25. Square this out. So I go over to my scrap paper. I square it out. I end up getting 4y squared plus, because negative 2 times negative 1 is positive, right? Plus 4y plus 1. Square this one out. Y squared minus 4y plus 4 equals 25. Combine my like terms. If you didn't get that, that's why you need to show all your work. So if you didn't get that, you can find your mistake. 4y not minus 4y is 0. 1 plus 4 is 5. I'm going to go ahead and add that here. Don't factor yet. Get it equal to 0 first. Sometimes you'll find out things disappear. Unfortunately, not this time. Factor out my 5. That gives me y squared minus 4. This time I can only factor out the 5, not the 5y. But I do notice I have my difference of perfect squares. So I can factor that as 5, y plus 2, y minus 2, 2, where to get a 12, 2 equals 0. So my solutions are y equals negative 2 or y equals 2. And when I go to find the rest of it, I can go right back up to this form of x. I don't need to go here because I got x equals here already. So I'm going to use that. So x equals -2 times -2 minus 4. -2 times -2 is +4, minus 4 is 0. So one solution is 0, -2. The other solution, -2 times 2 minus 4. So -2 times 2 is -4, minus 4 is now -8. So when x is -8, when y is +2. So again, we've got a secant line. Okay. And we could go through and graph that real quickly just to illustrate all of that. We could do that. I'm not really interested in that. If you want to graph things, you can. But for the homework, I did put homework on here. In fact, the rest of this page is your homework. And notice I did put graphs on there. The graphs are your optional use. Okay. What you're going to do is you're going to look at the problem, and there's going to be 2 questions for every problem. First of all, what are the coordinates of the intersections? If there are no intersections, type none. Okay. If there's 2 intersections, put them both. If there's only 1 intersection, only put one of them. Okay. Then tell me, is it a tangent line, secant line, or neither? Okay. So that's your homework for the night. Again, if you need help, show up for one of the live Q&A sessions at 2 o'clock on Tuesdays and Thursdays. That's when I'm holding those. And see you on the next lesson. Toodaloo.